¿Se me oye? ¿Sí? Yo creo que no. ¿Sí? Ah, vale. Buenas, vamos a empezar mientras están colocando el streaming todavía, pero vamos. No sé si sabéis, este es un Meetup que se va a hacer común entre la comunidad de Liferay y la gente de Java. Bueno, yo soy de la parte de Liferay. Por hacer un poco presentación y demás, nos solemos juntar una vez al mes, el último miércoles, normalmente. Por si os interesa, hablamos sobre Liferay, evidentemente, donde estamos ahora mismo, temas de desarrollo, de uso, funcionalidades. La última charla fue sobre diferentes usos que se dieron en sanidad. Entonces, bueno, son charlas que creemos que son interesantes. Por si os queréis apuntar, tenemos un grupo de Meetup que seguramente estará compartido también en la charla, y si no, lo pondremos luego en Twitter. Y poco más. Decís que ahora Milen nos dará la charla y que esperemos que os guste. Y si os queréis venir y apuntaros a la comunidad de Liferay, ya sabéis, ahí estamos.
Alright, it's my turn, I guess. Okay. I have no idea what he said, but I hope it was nice things. I hope it was nice things. I need to improve my Spanish, definitely. Hey, hello everyone, good evening. Glad to see so many people here in the middle of a week at this time. That's impressive. Thank you for being here. My name is Milen Jankov. I work for Liferay, as you've seen, as a developer advocate, which is basically a big part of that is going to the community, so to say. The people that use our products, not only our products, the technologies that we use, and try to understand how they use them, whether they use them in the right way or the wrong way, how can we help them, things like that. And part of that is doing talks about technologies that we use, about this thing that we've discovered while we work on certain things. And this is one of the recent talks, which is not really about Liferay. I'm not going to bother you with like how we built our products. The original idea was to actually do that, take the examples of our own code, but I figured this requires some time to understand, so it's a very oversimplified example of how to do application decomposition, or composition, depends on which way you want to look at it. In our case, if this works, in our case, it was most of a decomposition, because I don't know how many of you are familiar with Liferay as like what we do. For those of you who don't, we historically are the portal company. Everything we were building in the past years was one big portal platform, which grew to be so big that we needed to actually split it into bits and pieces to be able to maintain it. And this has been a challenge for a lot of in a lot of areas. And one thing that we discovered many times is that just getting a large code base and cutting it into smaller pieces doesn't actually make it better. So this is basically where this talk originates from. If you ever end up designing systems from scratch, but even more if you end up decomposing a large piece into smaller pieces, the ideas that I present today hopefully will help you somehow. The subtitle and the alternative title of this talk is Cleaning and Tidying Children's Rooms. And now a lot of people were wondering like, wait a minute, we're out of the technical land. If you parent, you will immediately understand what I mean. If you are not, you will understand with time. But I'm a parent of 3 kids, and when I go talk to software engineers out there, I realize that it's very much conceptually the same conversation I'm having with my kids. Just to give you an example, it's like I'm looking at a piece of code or code base, and I'm like, guys, you know what? This thing is messy, right? I can't make sense of what you're doing here. And they go like, what do you mean? It's perfect. It's great. It works. And that's exactly what my son says when I tell him, your room is messy. And he says, what do you mean it's messy? I said, it's okay. I'm perfectly fine in it. So this is very much the same conversation I keep having with like, okay, maybe I can use that as an example just so that to illustrate my point. How many of you are familiar with the Conways Law? I keep finding that surprising. How many of you are doing microservices? Yeah, that keeps surprising me, because Conway's Law is like a fundamental thing in microservices, but a lot of people don't seem to be familiar with. Well, in short, Conway's Law says that any organization that designs software is inevitably going to produce a software design that reflects the communication structure of that organization. Now, you may not agree with that, you may not recognize that is happening, but in most cases, that is exactly what is happening. Now, taking Conway's Law for granted, which again, we may have different opinions on, I thought, wait a second, if that's true, maybe we can flip it over just for the purpose of explaining things. So here's my reverted Conway's Law, which basically says that if assuming Conway's Law is true, then you can take the design of any software system and represent it as an organizational communication structure. Now, with that in mind, all of a sudden, you have a tool to illustrate how a software system actually behaves outside, using analogies outside of the software engineering field. So, I'm going to show you exactly this today. I'm going to be showing you like concepts of a company, organizational and communication structure, which kind of delivers from a software architecture, so you can draw the analogies yourself. All the code that you're going to see today is on GitHub, and slides I think will be available at some point, so you'll see the URL. So if you want to play with the code, feel free to do it later on. If you want to tell me how terrible it is, feel free to do it, even on public channels or on Twitter or whatever. So keep in mind the code has a very particular purpose. It demonstrates several, so to say, architectural styles. It's not, so it teaches you to think primarily how not to do things, right? So if you expect to grab the code and use it in production, that's the worst idea you can come up with, right? It's more of a look at the code of like how you should not do things, okay? And keep in mind, it's just a demo for a talk. So it's not bulletproof, it's not the perfect design, and so forth. So with that in mind, let me introduce you to Hari. Hari wants to start a business. And he thinks hard for a while, and he figures out he's going to be doing a house cleaning services. He's going to provide his house cleaning services to customers. He has some van, some tools, and some supplies. So people can call him, he grabs his stuff, puts it in the van, and then go clean the house, and then come back. And that's pretty much very simple business model here. I'm going to have to sit now. I'm sorry about that, but otherwise I can't work with the code. It's too low. So how we represent that with code. So here is a house cleaning example 1. If we look into the code, we have the Hari here. Let me close that for a second. So this is Hari. Hari has some tools, some supplies. He has the van. Like in his company, he needs to do some bookkeeping and things like that. So we, initialize Hari with all those things. And then what Hari can do is he can clean houses. What does that mean? Is he gets an address that where he needs to go, some instructions how to clean, some money, he's being paid, and then he figures out what tools he needs, what supplies he needs, he puts all the stuff in the van, then he drives to the address, then he cleans the house, he drives back, and he records some income in his bookkeeping system, right? Super simple. Now, Hari, apart from all that, is also a person, right? And now that he has a van, he can actually borrow his van to someone. So here's another thing that Hari can do. He can borrow a van. Of course, he doesn't borrow his van to everyone. He first checks if this someone is a friend, and he only borrows the van to his friends. And same thing with tools. He can borrow his tools to someone. So how do you like that design? That software architecture? I mean, come on, it's the perfect software architecture that you do on year one at the university, right? And it's super good in a sense that, think for a second about bug fixing. Something goes wrong, you know exactly where it is. It's hurry. It's like, no debugging, you don't go anywhere, search millions of classes, it's all here. Right? It's like the most efficient way of designing software, given that you don't have to evolve it over time. Right? But it works, and I can actually demonstrate that. And in order to demonstrate that with other projects, I have this thing called client, and it's just very simple user interface that I can use to interact with the stuff. So let's go to house cleaning 1 and just run it. I have a shell script to run it, and when I run it, I also need to say which Java version I'm running it with, and you will see later on why is that important. So for now, I'm running this with Java 8, and this is my interface, and I can say, hey, clean the house, and you will see the process going on, like Hari leads the, picks the supplies, the tools, loads them in the van, drives to some place, cleans the house, basically what we described, right? So this is this architecture, right? And it's great. It works, except it's not evolvable. You can't scale it, right? If Hari needs to clean more houses at the same time, he can't do it. So we start thinking about, Hari starts thinking about, maybe I should evolve somehow. So he's like, okay, I'm going to offload some work, right? All this like requesting stuff, dealing with customers, that's not for me. I'm the cleaning guy. I'm going to get Ronald. Ronald is going to deal with customers, like payments and all those things, and he's going to give me just something like the summary of the request, and then I go and clean. But also, he realizes those things are not actually part of him, right? They are part of, they are tools that he uses. So he abstracts them away in a thing that he calls garage, right? So this is we are already not having everything as represented as Hari, but we are splitting things into different places. That seems good. Let's see how that looks in code. So in code, that's the house cleaning example 2. So we now have Hari. Hari can do the same things as before. He can clean houses, he can borrow vans. Okay, I forgot to show you the borrow van thing. So now that we are still at the example 1, let's demonstrate that. So I can say, Hari, I want to borrow your van. Says, I'm sorry, but I don't know you. I'll say, what do you mean you don't know me? I'm a friend, remember? Oh yeah, sure, he can borrow me the van now. Good deal. Okay, so this is still example 1. Okay, so we're moving now to the example 2. Why I can't close this for some reason. Anyways, and it's the same thing as far as Hari is concerned, except he now has Ronald at some point, and Ronald is dealing with, all the customers. He has this order form, customers can fill in, and at some point in time, Ronald is going to call Hari and say, I'm done with, the processing the order, so go clean the house. Now, the other interesting thing is the thing called garage, which holds all these things. And the garage is basically what I call it in here. It's smart garage. It's like, you know what smart garage is? It's one of those smart things that allows you to do things like select from. No one in this business actually needs those. And most of the time they don't, but everyone does. So when you look at the industry, you see everyone is using them, so you use one as well, right? And so Hari does. So he uses this smart garage to be able to select the tools and stuff like that. And so I can demonstrate that this works. Let's close this and go to house cleaning 2, and run again that with Java 8, and I can say clean the house. Not clear. not this clean, clean the house. And you see the process is very much similar, except we have now Ronald, taking the order form here, and other than that, Harry is doing the stuff. Now, what happens if I ask to borrow the van? Let me borrow the van. Here goes. I have the van. I can now go on vacation, and Harry's out of business until I return, if I return. Well, then wait a minute. How'd that happen? Why no one asked me if I'm Harry's friend? Well, it happened because of this. Because now that we've separated things from Harry, there is absolutely no problem for Ronald when I'm the client. So I don't talk to Harry, I talk to Ronald. I say, can I borrow the van? So now Ronald can do one of the two things. He can ask Harry, or he can just go grab the van and say, hey, here you are, go. No problem. Right? So Harry goes like, no. This is not one. I don't want things to work this way. Now, you may argue that I did this wrong in terms of code. And because if you look at the garage is in the same space, like in Java terms, in the same package, right? So it's available to Ronald. So maybe we should try to hide that somehow, or isolate, or whatever you want to call it. So this is obviously what Harry decides to do, and he's like, okay, I'm going to restructure my company in a different way. And by the way, I'm gonna hire another guy, Andre, to help me with tools and stuff. So the thing all about the Ronald stuff, I'm gonna call it the front office, right? And the front office is gonna take care of my customers. They talk to me and to me only. Now I'm in charge for the garage and the van, and Andre is like in charge for those things in here. Like tools and supplies, so I tell him, like, when we get the order form, he knows what to prepare for me. More optimizations, right? So let's see how that works in terms of code. So that's example 3. I'm going to close this so it don't bother me. And I'm going to close this. So here we have not only separated things in classes, but also in modules, right? So we now have the company module, which is where Andre and Harry are. So this is Harry again, same thing. But if you look into Andre is now not publicly available to anyone except to Harry, right? And we also have the assets module, which is where we keep all these things, the garage and the storage and stuff like that. And of course we have the front office, where we have Ronald with all his stuff. So if you now try to go and run that example, let's run it again with Java 8 and do the same exercise, clean the house. Yeah, it works. Ronald accepts the form, Andre prepares the tools, and everything works just fine. Borrowing the van, though, oops, happens the same thing. Why? Why no one ask for friendship? Because now Ronald can bypass, again, both Harry and Andre. And so how we prevent that from happening? Well, you can argue that we can hide those things from not make them publicly available. So the first thing that comes to mind is say, wait a minute, I don't want this garage to be available to everyone. Sounds like perfect solution, except in this particular case, it's also not available for Harry. All right, so now Harry can't do the business. So with this architectural design, you basically have no other options but keep that thing public because Harry is also out somewhere, right? And he needs to access it, and you have no means of saying other than implementing your own custom logic in there, basically saying that, well, it's only visible for someone, right? So Harry goes like, nah, that's not a good idea. I'm going to change my company. I'm going to restructure it again. But before that, he talks to consultant, explains the problem, and the consultant smiles and says, well, you just invented the universal BBC architecture, which is the Buzzbox Cylinder. That's, you may think that this is something that is terrible, but if you're old enough and you have white hair, you know that for many, many years we were told that this is the best architecture ever. Right? Well, we don't call it Buzzbox Cylinder. We call it typically front-end business logic database and all kinds of other names. But this is how we've been out building applications for many, many years. Now, that we know it doesn't work this way always, or it has drawbacks. Harry goes like, okay, I'll do something else. I'll stick with Garage with me, and I'm going to protect it, right? So no one has access but me. In my company module, in my company building. And in back office, I'm going to put Andre, and then he's going to guard the storage. So no one has access to the storage except asking Andre, right? And then Ronald's going to talk to me, and I'm going to talk to Andre. So that's perfect. That solves all the problems that we have. So in terms of code, this works. This is the fourth example. So here is the back office again. Here's Andre and the storage. So in the company, there is Hari and the garage, and you see the garage not publicly available to anyone. Same the thing with the storage. And in the front office, obviously there is Andre with his own, Ronald with his order form and stuff like that. So will this solve the problem? How do you think? Exit, and we're gonna go to house cleaning 4 and run it again, and let's see, it works. Let's make sure it works first. So yeah, same thing. Ronald, Hari, and Ray. Good. Can we now borrow the van? Nope, because now Ronald has no other option, but he needs to ask Hari, and Hari is gonna say, "Are you my friend?" But can we borrow the tools? Of course we can. We just got the tools and we go home and Hari has no tools, he's out of business. How the hell did that happen? Well, that. Now, he cannot go straight to those things, but he can bypass Hari and go to Andre. Now, so the only option for you to ensure that no one who is not a friend of Hari gets access to the storage is explain to Andre who are Hari's friends. Now, it's super easy solution. Make sure that Andre knows about all the Hari's friends. So every time you ask Andre, he can tell, oh, I know you Hari's friends, so I give it to you or not. I'm not quite sure you want to implement that, but funny enough, this seems to be what a lot of people these days do in terms of architecture, and what I call the universal microservices architecture. It just isolates things in boxes, and in terms of that box, they're pretty well-defined boundaries, but then you end up in a situation where each box has to talk to pretty much any other box. And then you have to duplicate logic from here to here in order to ensure consistent behavior. Right? So that may work in some cases, but seen way too many cases where it doesn't actually work that well. And at this point, Hari realizes, you know what? It's not about people. It's not about me and Andre and Ronald. It's about the company. It's about processes. It's about how we operate. So let's forget about people for a while and start talking about business model, about how actually things operate. So what is the company? A company is a group of things like job positions, which implies what one can or cannot do, like processes, like assets, and stuff like that. Now, what the company does is use cases. Those are the things that you actually can do with these resources, right? So this is the resources I have, and this is what I actually provide to you, given that I have those resources, and this is how I interact with you. Now, that opens the door for future improvements, because given the same resources that you have, you may provide different use cases. So if Hari tomorrow wants to provide, instead of only cleaning the houses, like cleaning swimming pools, or cleaning backyards, or cleaning whatever, right? Those are just more use cases that make use of the exact same resources that he already has. Or he can evolve grow his resources to be more productive without actually changing the use case, the service that he actually provides. Same thing with the front office is, right now people need to go to run out and order stuff and things like that. Maybe in the future he wants to provide a different way of interaction to his customers. Well, that's improving that bit here. He doesn't have to absolutely deal with these guys here. So, code. I'm going to close this again. That's example 5. So, in here, we have divided the company. So this is the company. And inside the company, we have these things, again, called modules. So here are the assets, the vehicle, the storage. So now we have, apart from other things, we don't have only people, we have job positions. And if you look into a job position, for example, accountant, that is not something set in stone, and that's not a physical thing. That's a role. Who is an accountant is a role that describes what you can do. In Java, we call those things interfaces, right? So the accountant is an interface, and it tells you what it can do. It can record an income. Same thing with, for example, cleaner. Cleaner is a role. Cleaner, clean houses. Or you can do more things. You can define more things for that role, but it's the role that you care about. Now, if you look into the staff, now here is where we have Hari and Andrei and Ronald. And if you look, for example, at Andrei is an assistant. So now when we say, and this is, if you think about it, this is exactly how we deal with this problem in any business. You hire a person and you say, you're going to play that role, which means you have to be able to do these things. We don't really care how. We just know what his responsibilities are. And if you think, and some people, like Hari in this case, they play multiple roles in the company. Hari, for example, is both the cleaner and the accountant, because why not? Right? So now we're describing the company and the processes and the structure, and not the characteristics of individual people. The next thing is processes. So what actually happens when people want their houses to be clean? Well, we initiate a process. And for example, here is a CleanHouse process, which basically means grab someone who is in the role of cleaner and ask him to clean the house. But that is like the end piece of that. If for the order process, for example, here is how it goes. It has to be able to check the payment, right? And then prepare the instructions. That's your order process. You receive a request to clean a house, you check if they have paid you enough, and then you prepare instructions for people to actually clean the thing. And there is something called transport process, which is basically how you move yourself from your location to the house that you have to clean and back. So those are business processes, and of course between all those things you have to share some stuff, like policies, for example, for pricing and stuff like that. So you put those somewhere there. So that's pretty much how the company is organized. And then you have the use cases. And in use cases, it's basically you define what you can do with those things. So here is a clean request. Here's a customer use case that says clean customer house. So how do you deal with that? Well, it consists of executing several processes in particular order. First is process the order, so make sure we paid enough money and so forth. prepare stuff for, that you need to use to be clean. Then you need the CleanHouse process and the transport process. And this is essentially what it says. Is check the payment, and then prepare for the cleaning, then use the transport process to go there, use the house cleaning process to clean the house, and then the transport process to go back. So use cases is basically defining how we get things done. And then you have the front office in here, which is basically the same old thing, run out with the order form, except we just define it in terms of processes. So when you get the cleaning request, what happens to you? So make sure that works. Come on. House cleaning 5, I think I need to go there. Let me shorten this. Okay, so house cleaning 5, and I'm gonna run this again with Java 8. So just to, and I changed it a little bit here. You need to provide the amount of money. So now that we have a process, so if I say clean my house for 10 euros, the first process is not gonna fire the next one because it's like you don't pay me enough. But if I say clean the house for 100 euros, totally fine. We can start the processes. And as you can see, it results in the very same thing, different people doing their things to do, but we don't deal with people this time. We deal with the company processes and the roles people play in that. Nice. So what happened to our borrowing thing? Borrow van. Yeah. Why? Can we borrow the van? How do you think? Of course we can. Hey, we did so much, design work and architecture work and stuff like that, and still haven't solved that problem? How is that possible? Easy. Now your front office can skip the whole thing in here and just go and talk to these guys here, right? Why? Because why not? And we have the same problem. You can try to isolate those. Say those are not public facing, right? Remove the public word whenever you see it, but then your use cases cannot use that. So we're stuck in the very same situation. And if you think this is artificial, think about how many times you had to deal with creative developers who found a way to work around the intended functionality of your software. Right? And every time you do this, every time you see someone figuring out like, okay, I'm going to skip this business logic module, I'm just going to go to the database, grab this thing, and then I'm going to update it here because I know it at the end goes at the database. Right? You've never seen that. Never happens, right? Okay. So how do we fix that? Well, what if we could hide those and we could tell that those things are internal. Those things only exist in this scope, in the company scope. And no one outside of that company scope can actually deal with them. How can we do that? In Java. Like, almost not possible. Well, it wasn't possible before Java 9 showed up, because Java 9 showed up with something called JPMs, Java Platform Modular System. How many of you are familiar with JPMs? Like 2-3 people? Wow. Okay. So this is the next example, which is in terms of code almost equivalent to the previous one, with a few small differences. The first one is in the company. So when you look into the processes that we have now, one thing you realize is, let's take transport process for example, no. Okay, so they are in these packages like job positions and processes. But when you look into the assets and shared and other stuff, they are into this package called internal. Okay, so we don't protect things by just calling them internal. I mean, it's good practice to explicitly tell people, do not touch, I meant you to not touch this. But they're going to tell you, screw you, I need this, right? Constant and safe, you know, things like that. But in Java 9 and every further version, we can actually explicitly say what we want to be public. And this is done by the file called module info. And so in here, we're basically saying, I want to export these 3 packages outside of my module to be able for other people to use them. Anything you don't export here is, for the outside world, it's like it doesn't exist. Well, it's not really true. They can still see it's there, but Java runtime will prevent you from actually instantiating classes in those packages. Right, and then on the flip side of that, for example, the use cases in this case, you also build that as a module, and then you say, well, for this to function, I actually require the house cleaning company module. Right? So from one side you say, my module only gives you this, and from the other side say, I need those modules in order for me to properly function. Right? So the tricky part in here is that you actually need Java 9 or newer for this to work. So if I go to house cleaning 6 and compile this, we just compile this, which by default uses Java 8. Was it, or no, by default is now using Java 9, sorry. So I changed my, so again, if I say use this with, compile this with Java 8, it's going to compile just fine, as you can see. And I spoiled the surprise, because my next question would be will this compile again with Java 9? And you already see that it doesn't. Or if I try with 10 and 11, I'm going to get the same result. I'm going to have failure at front office. And if you look into what it says is package company internal assets is not visible. You are trying to access something that you have no access to. You're forbidden. So the clever developers doing the front-end stuff now have to go in here and say, crap, can't do this anymore. And they probably need to do something like that. And because it's Java, you also need to fix the imports, right? So once you fix this, and you go to do the same thing with Java 9, now it compiles, or it should. Okay? And so just to demonstrate, but now the downside of that is, if you try to run this with Java 8, sorry, it's not going to work, because, you know, for the obvious reason. So we need to run this with Java 9. Now with Java 9, you have, and every newer version from Java 9, you have two options to run things. Either on the class path, which is the compatible mode with the previous Java versions, or on the new module path. And in order for modules to work, you have to run it on the module path. So I'm just going to run this with Java 9 module path, and we have the same interface that we had before. And as you can see, CleanHouse now works. And if I try to borrow the van, I can't, because guess what? Our company does not provide that service. right? So you can't even request that. Same thing with tools. That's great. It took us, what, 6 iterations of different architectures to be able to hide those things, right? But now, as you know, in software engineering, you know what happens when you solve a problem? You encounter the next one, right? So the next one is, like, we have these processes, we have all this, you know, cool things, and in here we have a transport process. And transport process heavily rely on the fact that we can always get our van and go to the customer. What if the van breaks? What happens if the van goes out of order and it's in service for 3 months, right? I don't know how fast van repairing works in Spain, but I know countries where it's not that fast, right? So you don't want to be in that situation. So I have some code here that simulates that very situation, which is in this file here in called status. And in here, I have this field called van functional, and if I remove the true, as basically I'm saying my van's broken. Okay, so I just broke my van. So what's sorry, wrong window. So how do you think, what's going to happen now if I request to clean the house? Boom. We can't, because there's no way to go to the client. You know, there's no van, transport process is broken, like, there's nothing you can do about it. How can we fix now that problem? That's a different set of problem to deal with. Well, one thing to do is to allow, or I'm just going to show the code first, is to switch to service-oriented architecture, or how was it, SAW? Service-oriented architecture, or as other people are calling it, microservices. In both cases, it's about the same thing, abstracting the service definition from the service implementation and isolating and encapsulating the service so that you can replace services when you need to. But if you think I'm going to have to go all the way with Docker containers and Kubernetes and stuff like that, there's no way I'm going to do that during this talk. So I'm going to do something different. I'm going to use a feature of Java, which was introduced a long time ago, and it's called Service Loader. How many of you are familiar with Service Loader? Java Service Loader. 1, 2, 3, 4, 6 people. Guess what? Service Loader was introduced in Java 6. That was quite a long time ago. And in Java 9, the only difference is that they moved the definition of the services into the modular descriptor before you had to use properties files. How that works is, so in our company here, you see a change. Now, our processes are no longer solid classes. So let's say here's a transport process. So we now use the same thing that we use with the roles. We basically say, well, if something is a transport process, it must be able to go to a given, to move me from this place where I am to a particular location with those things in it, right? And then some other things. Like, then you implement those. But how you implement a process is a company-specific thing. It's internal. No one needs to know what is your internal strategy for transportation. It's your business. No one else outside should care about that. So again, in the internal package, we have the implementation here, which says internal transport process. And this basically says, well, in our company, we do transport in this way. We get the van, we load the stuff in it, we drive, and blah, blah. This is how our company does things, right? Now, from the outside world, you need to be able to connect the definition of the transport process with the actual transport process. And since Java 9 and in your version, you do that in module info. You say, this module provides a transport process with internal transport process. You basically say, this is my definition of a service, and this is what provides the service. You can have a comma-separated list here of more implementations of the same service if you need to. Okay, so what's the flip side of that? Well, the flip side, who consumes that? That use cases consume that. So in use cases module and module info, you basically say, I'm using these services. I'm using a new orders process, the transport process. Those are the services that I need to be able to have access to. So in terms of code, though, how do you use this in the code? If you look into the customer use cases, it's a little bit tricky. So you use this service loader load, and then you have to do some custom logic, making sure the services are actually provided and what you do if they're not provided. And it's a little bit troublesome, but it's not a huge deal. Right, so this is the fundamental difference between this example and the previous example. Now, what that allows you to do is to have multiple implementations of the same service. So what you would do in your company if you wanted to ensure that even if your van is broken, you can still go to the customer. Well, you're going to go and sign a contract with someone who provides transport services, like Uber, for example, right? So here is the UberTransport module. And the UberTransport module basically says, well, we are providing a transport process with a UberTransport process. And the UberTransport process basically says, oh, call Uber, get in the van, go there, call Uber, go back, right? It's a different way to go from where you are to the house and back, but it serves the same purpose, right? Now, unfortunately, what Java 9 and every next version of Java does not allow you to do is dynamically replacing modules. Well, yeah, that's not entirely true. You can still use layers and stuff like that. You can make it work, you know, yourself, but it's not an easy task to do. So when you run your code, you have to explicitly tell it which modules you are running with. So in this here, I'm going to have to say, apart from those modules that I was running with before, I also want you to run with the UberTransport module. So now we are providing two modules that deliver the two different implementation of the same service. In our code, we have some heuristics that make sure that if our company service is available, we use that, and only if it's not, then we use Uber. But I'm not going to bother you with that code. If we go now to house cleaning 7, and let's compile again this just so that you make sure that it's all compiled properly. It should work with no issues. But again, this requires version of Java 9 or newer. And then you run it again, not compile it, run it. So here is the thing. CleanHouse, just to make sure it works. It works perfectly. Okay, so status. Let's break the van. Clean the house. Works. I just use a different meaning of a transport process. I called Uber and went there. Sorry, I realized the bottom of the screen, so I'm going to call it again. Here it is. So now we are using a Uber van to go there. Now, but what happens if our van is fixed? Let's clean this again. Here are using our process, our own in-house processes again. So that gives you the flexibility to adjust to failure. If one service is not available, you just use another service. That service could be provided in-house from your own module, from your own company, or it can be provided by other modules or other companies in this particular case. The problem with there are two things you can't do with this that may or may not bother you, and they bother me. One, I can't do this dynamically. If I forgot to start my application without the Uber process, I can't add it. I need to shut down the whole application, add the module, and start it again. I don't want to do that with my business. I don't want to close my business, go sign a contract with Uber, and then go back and open my business again. That's not how we work. At most times, we want to have things dynamically at hand when we need them. But the other thing is, you can't do this with any older version of Java. If you're stuck with Java 8 for whatever reason, can't do this. I mean, not that you can't. You can. You just have to use services in the old-fashioned way, but then you are not solving the previous problem that we had with the access, right? So how do I solve both of those problems and make it dynamic in Java 8? Well, the answer is OSGI. And here is how it works with OSGI. Let me close those things. And here is the final example of today, which is very similar to what you saw before. It's almost identical to example 7, but there's differences. We don't have module info here, which is a Java JPMs specific things. Instead, if you look into the company in here, we still have the processes, the transport process, for example, as still a definition of a process. An internal transport process is the implementation, but we declare it as a component. So now that is a framework that is popular in the OSGI world called Declarative Services. You can think of it much of a like CDI annotations or inject or spring beans or whatever. That basically says I'm a component and I need to be registered as a component. And I'm not going to go into too many details how that exactly works. Now, on the consumer side, if you look into the Uber process, use cases, you will see that in here we now reference those processes. So that is asking for an implementation of a CleanHouse process, asking for an implementation of the new order process, and so forth. And as you can see, the code in here is much cleaner because we are relying on third party to actually inject those things into our implementation. Now, obviously, for this to work, you have to use some plugins. So if you look into the some Maven plugins in this particular case, now what makes the magic happen is using things like BND annotation for the annotations, and using the BND where it is, Maven plugin, which is basically inspecting those annotation and wiring things, making sure that things are wired properly. So your POM becomes a little bit more complex, but that's basically to just set up the build process to be able to take these things into account. And that's pretty much it. So now how that works. If I go to house cleaning example 8, you will see that I can now compile it with Java 8 without any issues, hopefully. So it all compiles nice. And I can run it. Now the UI, the user interface, the shell is going to be a little bit different, but it's familiar. So I run it with Java 8, and I have more or less the same interface, it's just different tool here. So I can say CleanHouse and here I have to type it, I didn't make the comment properly, so for €100. The opposite. This way? Yeah, here we go. So you see the process we use is pretty much the same. Now, what happens if my van breaks? Obviously, it doesn't work anymore. It's the transport process is missing, right? We can't do anything. Now, in this case, what I can do is I can say install and go to my UberTransport process, get the artifact in here, and install it. I just install a module in the runtime. And this is the modules that I have in the runtime. So I can now go ahead and start that module. I can actually automate it to start when I deploy it, but that's a different story. Just make sure it's there. It's there. Okay. So if I say now clean the house, here it is. I'm using the Uber process. And if I say wait a second, my van was just repaired. And I can say, let's show it on a bigger screen, higher in the screen. So I'm not now using my internal process again. So obviously I can have more than one fallbacks, and more complex logic of how do I want to deal with fallbacks. What we have done is this. So not only that we hide all those things that we know are internal and no one outside our own company should be caring about those. So those are protected now. They are internal stuff. Those need to be available as their communication points with other things. But we also introduced a notion of a services layer, an abstraction, right? In the case of JPMs, that was the service loader, and it's pretty much static. You declare it in some files, and then it looks in the class on the class path or the module path, and that's what makes it static. But it works for simple use cases. In the case of OSGI, that is a whole specification in the OSGI platform and about service registry and how you interact with service registry. And here you can do a lot more interesting things. Like in this example, this is very simple because we basically say, give me an implementation of that service. But what you can actually do, you can query the service layer, and you can say, give me an implementation of a service that matches a filter. Or I want only the services that are provided by a particular provider, or whatever. The dynamic nature of OSGI allows you to actually be much more flexible about how you interact with the service registry. In JPMs, you only have two options. Give me the first service or give me all the services, and then I'll choose one, right? So this is the architecture that we reached that solved these two problems. Now, in the real world, what's going to happen is you're going to face the next problem. In here, I've taken enough of your time already, so we're going to stop at this point. But the point I'm trying to make here is it is very important for you to realize not how your structure, how your application architecture looks today. How it looks today is largely irrelevant. The bigger question is how it will look tomorrow. Do you know how it will look tomorrow? You don't. And that's the point. I don't. No one knows. Right? So the question is, are you prepared with your architecture for tomorrow? In terms of, do you know how much it costs you to adapt to coming changes? And this brings me to another famous saying that says the two hard things in computer science: cache invalidation, naming things, and off-by-one errors. And how many of you believe that naming things is the hardest? Right, okay. You may disagree, but I believe it's not only the hardest, it's the most harmful one. And the reason it's the most harmful one is what happens is people chase the opportunity to label things, to coin words. And like, let's take one for example. Let's take agile. Do I have it here? Agile. Here it is. So what happens is a bunch of smart people figure out there is a problem in software practices. Like we're doing stuff wrong over and over and over again. And they got together and they figured out that maybe if we change the way we build software, if we change the way we organize teams, we change this, if we do that, we'll be able to deliver a better software. The biggest mistake they made, they gave that thing a name. They call it Agile. Now, what happens after that is you have a bunch of people all over the world that are Agile experts, right? And you have absolutely no idea how related they are to the original concept of Agile, but they're the Agile experts. And so you end up having someone telling you, that's not Agile, that's Agile, right? That's not how you do it. If you don't have stand-up meetings, it's not Agile, right? And we have these stupid discussions about a word, about a meaning of a word. Not about how we improve the processes, how we improve our software delivery, how we improve our code, but what the word means, right? If you don't use Spring Boot, you don't do the microservices, period. Okay, right? So to me, that is one of the fundamental problems with naming things. The moment you stick a label on it, you start operating on the label level, and then you start arguing about what that label means. And that is exactly the same thing I realize I'm doing with my kids. I'm using a label. Clean your room. If I were my kid, I would look back and say, define clean. Right? And it would be the perfect answer. Like, what does it mean, clean room? Clean room for me, it's totally different thing that is clean room for him. Which brings it to the point, hey, wait a second. Why in the world I want him to clean his room? Why? Because I'm like a nasty father and I want to make him do some work? No. Because I have concerns that if the room is not clean or not tidy, he may hurt himself. I may hurt myself getting in there, right? I have my reasons to demand clean room. But I don't express my reasons to him. I say, go clean your room. Right? And he goes like, it's clean. Right? And it's the same thing we do with software. We don't express what actually our concern is. We don't express the problem that we're trying to solve. We just use a label. I'm going to do microservices. Good for you. Right? Well, here's the thing. No matter how you define it or what you do, in the most clean and tidy room, over time, it's going to become messy and dirty. By whichever definition, mine, my son, some other people, right? At some point, it's going to be messy and dirty. It's not about cleaning the room today. It's about developing a habit of looking at the room and thinking, does it look messy? Is it, if my father comes tomorrow, will he be screaming on me or not? Right? That's what we want from them, to have the habit of cleaning the room. You're not going to make it like, why this toy is on this shelf and not on that shelf, right? Because that's not important as long as it's not on the floor, right? But we want them to build a habit to clean after themselves so they live in a safe and in a livable place. And guess what? It's the very same thing with software architecture. We just want people to build software and to design application so they are developed and maintained in a they are safe and livable place for developers, because that's what we do. We live in the code, so make it livable. Thank you. I'm happy to answer questions if you guys want. I'm not quite sure how that works organization-wise, but...
We have a mic.
Okay.
¿So hay questions? ¿Tienes preguntas? Si ya tanto lo preguntan en inglés, lo podemos traducir. Adelante.
Shocked. Sorry, didn't want to scare you.
I think almost all the companies are using Java 8. Nobody uses are using Java 9.
No, honestly, I haven't. I now starting to see companies starting to use Java 11. The obvious, I'm not sure if it's the right explanation, but the obvious explanation is that Java 9 was not supposed to be a long-term support release. It was only supported for 6 months and was replaced by Java 10. Java 10 was supported for 6 months, and the first release of Java after 8 that is a long-term support release is Java 11. So many companies, including Liferay, decided to basically skip on Java 9 and Java 10 because it doesn't make sense to invest into modifying a large code base on something that only has 6 months of lifespan, right? So I'm guessing that is the reason. The same thing with not only companies and their big softwares, but also in terms of like monitoring Maven and libraries and stuff. How a lot of people were complaining like, well, not a lot of libraries are modularized for to work with JPMs. Well, it was the same thing. No one knew what's going to happen by the time Java 11 is released, right? They may have keep the same modular system, or they may have changed it, in many different ways. So people were just backing off and say, okay, until a long-term release is out there, so I know that whatever I do, it's going to last on the market for at least a couple of years, right? It just doesn't justify the effort to. So the only effort I was seeing during the last year or two was experimenting. Like, let's just try it out, see if it doesn't cause too many problems, maybe we go with it. But if it causes problems, we'll wait for 11, right? But I think it's going to start happening now after 11, because 11 is a long-term release. Any more questions? Yeah.
Can you please clarify the difference between SPI and API?
Okay, so that is the part of the talk.
Another
yeah,
second question is for the last example you showed. You are using an enterprise service bus or a minimal enterprise service bus to use OSJ?
No, that's just the functionality of OSJ. You mean? Let me go back to. You mean for that thing? No, that service registry is part of OSGI spec. It's actually part of the core spec. So every time you start an OSGI runtime implementation, you have this for granted. It's there. It has to be implemented by whoever is implementing the OSGI spec. So both Felix, Equinox, and others like Knopperlfish, whatever, they all have it. For the previous question, so this talk is typically longer, and I was debating with myself, should I go on until the end, or should I stop it here? And this is typically the place where I stop it at conferences because of time constraints. There's two ways to answer your question. One is theory, the other one is to show you an example. But showing an example means another 15 minutes, so I'm not sure you guys want to spend that time. And in what it boils down to, the difference between SPI and API is it's the same as difference between providers and consumers, which is surprisingly very hard to understand. It was very hard to understand for me. So let me try to explain that without actually doing the code examples, which is going to take more time. Now, imagine you are building a logging framework, okay, like Log4j or something like that. And now you build it, you release it, right? What you typically have is, sorry, not Log4j, but more of a like SLF4j, right? Which is an API. And then you have different providers, like loggers behind it. You can use Log4j, what is the other one? Yeah, Commons logging, whatever, right? Now, you release that, version 1. Okay. And then you decide that you're going to add a method to your API, to the interface that people are using to call you, right? So you have like log info, log debug, log blah blah blah. That's an interface, let's say so. And clients are calling this, getting your class log info, log debug. Now you add a method saying log my custom event, right? How many consumers of your API are affected by that change? None. No one. Because, well, they can't use the new method, but they can use all the other methods the same way they did. They don't have to do any work. They can replace your library with a newer version, with a newer method, and still using it without any problems, right? Those are your consumers, and those are the people who you provide APIs for. Now, how many of your logging implementations have to change? Like all the frameworks that actually do the logging. All. Every single one of them have to implement the new custom method that you just created in your API. So in this particular case, what happens is you add a method and you break all the providers and you break 0 of the consumers, right? And now it's very easy to draw the conclusion that this is always the case when you add a method, right? Now, consider a different example. You're not a logging API, but you are a scheduler API, where people register services with you so you can call them at specific time. A typical scheduler thing, right? The same thing, you provide them the interface, they implement the interface, register their service, and when the time comes, you call them, right? Now, you decide to add a method to that interface. How many people, how many clients of yours you breaking? Everyone. Because what they need to do is they need to implement the new interface in order to consume your new service, right? Now, the change that you made in both cases is exactly the same change. You add a method to the class, right? The difference is, in one scenario, you only break the providers. In the other scenario, you break the consumers, all the consumers. And what OSGI does in this respect is have the notions of providers and consumers, right? And what you typically need to do, OSGI or no OSGI, is you need to separate the means of the two. If you put an interface that is both provider and a consumer into a same package or to the same module, right? What essentially happens is you are conflicting the means of two different things, because every time you upgrade so at the end package or module changes, right? But you don't know just by looking at the package or the module what was the reason for a change and who is going to break, right? When you separate APIs and SPIs, so SPI is a service provider interface. So when you have a separate module for APIs and a separate module for SPIs, you can evolve those independently. So you know every time you upgrade you change the SPI, your clients are still working, right? You're not breaking anyone, right? They're still compatible. But the moment you upgrade the API, you're breaking everyone. But then from provider side, it doesn't make any difference. Whichever one you change, they all have to adapt, right? So that's the fundamental difference. Again, it's not how you structure the software for today, because for today it doesn't matter. For today, you're going to do whatever fits your use case, and you have 100% knowledge about your use case. The hardest question is what you're going to do tomorrow, right? What you need to be able to adapt at very low cost and in a very short time. Okay? Any more questions? They don't like me.
Pues ya está.
Thank you guys. Thank you.
Bueno, pues ahora mientras que vienen las pizzas y demás, vamos a hacer la rifa acostumbrada. No sé, los que no habéis venido normalmente, pues en el JUG, en el Java User Group, normalmente sorteamos una licencia de JetBrains, ¿vale? No sé si conocéis JetBrains, el IntelliJ, el editor. Vale, pues la sorteamos utilizando un jueguecito que ponemos unas cuantas preguntas y podéis contestarlas utilizando un teléfono móvil. Y bueno, pues el que gane se lleva la licencia. Entonces es una cosa que pretende ser divertida y demás. Así que os animo a todos a que participéis y después ya tendremos las pizzas ahí para hacer un poquito de networking o hablar o preguntar a Milen o entre nosotros lo que queráis, ¿vale? Entonces...
Bueno, vamos a empezar. Bueno, no hace falta cortar si acaso la grabación, pero...
Sí, voy a...
vamos a empezar poniendo una velita a la divinidad de Kahoot, ¿vale? Porque la última vez que intentamos hacer esto, Kahoot se cayó. Entonces, en mitad del concurso, tuvimos